we are covering the effective stress principle, a critical topic for the FE civil exam. This principle is the absolute foundation of modern soil mechanics, and you are guaranteed to see it tested. The core relationship you must know is that effective stress, denoted as sigma prime, is equal to the total stress, sigma, minus the pore water pressure, U. You can find this exact formula in the Geotechnical Engineering section of your NCEES FE Reference Handbook. Total stress is the easy part. It's simply the weight of everything above a certain point, soil solids and water combined. You calculate it by summing the product of the unit weight and the thickness for each soil layer above your point of interest. Pore water pressure is the pressure exerted by the water in the soil's voids. A critical exam point is that this pressure only exists below the water table. To calculate it, you multiply the unit weight of water, which is 62.4 pounds per cubic foot or 9.81 kilonewtons per cubic meter, by the vertical depth from the water table down to your point of interest. The most important concept to grasp is that effective stress governs a soil's behavior, including its strength and how it consolidates or settles. Total stress is just a weight, but effective stress is the force that presses the soil grains together, creating frictional resistance. Let's walk through a typical exam problem. Imagine a soil profile with 10 feet of dry sand over 15 feet of saturated sand. The water table is at the 10-foot depth. The dry sand has a unit weight of 115 PCF, and the saturated sand has a unit weight of 125 PCF. The question asks for the effective stress at the very bottom of the saturated sand layer, at a total depth of 25 feet. First, calculate the total stress. This is the weight of the dry sand plus the weight of the saturated sand. That's 10 feet times 115 PCF plus 15 feet times 125 PCF, which gives us a total stress of 3,025 PSF. Next, calculate the pore water pressure at that same point. The point is 15 feet below the water table, so the pore pressure is 15 feet times the unit weight of water, 62.4 PCF, which equals 936 PSF. Finally, effective stress is total stress minus pore pressure, 3,025 minus 936, which results in 2,089 PSF. A common exam trap is to use the wrong height for the pore pressure calculation. Remember, it is only the depth below the water table. Another trick involves capillary action. If a problem mentions a capillary zone above the water table, the soil in this zone is saturated, but the pore pressure is negative, creating suction. This negative pressure increases the effective stress, making the soil temporarily stronger. For a memorable shortcut, just think of the name SU. Stress total minus U, pore pressure, equals effective stress. On the exam, if you see a question asking what controls soil strength or settlement, the answer will always be effective stress. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.